Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle, and I'm here with my co-host Gary LaRude. In this episode, we're going to continue to cover our May IMS and 5G issue. As a reminder, the coverage feature is entitled Anatomy of the 5G Small Cell, and it covers the Small Cell Forum's report about a common modular approach to the architecture of small cells similar to what Open RAN is. It goes into the detailed look at the RF front end and the block diagram that goes with that, different configurations for TDD and FDD small cells. I'm also doing a podcast with the Small Cell Forum report authors, so that would be a great thing to catch. I should have that published in a couple of days. Gary, what do we have for product features?
Well, we have some really interesting product features this month, particularly looking at frequency spectrum above 100 gigahertz. As applications move up into those ranges, of course, test and measurement systems have to cover the bands with the capability to make accurate measurements, and phase noise is particularly challenging. So Anapico and Virginia Diodes have teamed on a technique that measures phase noise to 1 terahertz using down converters from Virginia Diodes with Anapico's signal source analyzer and 2 independent local oscillators. So the 2 measurements can be cross-correlated, which suppresses the uncorrelated noise. That's a pretty elegant approach. Then Aravant has released a new sub-terahertz frequency extender. Theirs covers 220 to 330 gigahertz, and they can achieve 5 dBm nominal output power. The extender uses several multiplier stages to multiply the source frequency by 18. And the final stage uses a pair of Schottky varactor diodes that were fabricated using a film diode process developed by ACST in Germany. Another elegant solution. Then we have from 2Pi Labs a 126 to 182 gigahertz ultra-wideband FMCW radar. And this platform is available in 2 versions, one that can be used in a lab, the other can be taken out in the field. And for distance measurements, the 2Pi Sense radar achieves a range resolution of just a few millimeters and a range accuracy in the single-digit micron range. So that's pretty amazing. And then rounding out our product features, Roden Schwartz has a measurement receiver that calibrates signal generators and attenuators with just a single instrument, so it reduces calibration complexity. And it characterizes the modulation quality of the source and also has options for adding a signal and spectrum analyzer and phase noise tester, all in one box. So Pat, how about the tech briefs?
We also had 4 tech briefs, but those are impressive products. I mean, I can't believe we're talking about so many products now in the hundreds of gigahertz, even up to a terahertz. Very good accomplishments by those companies.
Really?
For tech briefs, we had a programmable ball and wedge bonder designed for versatility from Westbond. We also had sub-terahertz programmable tuners covering WR6, WR5, and WR3 bands from Focus Microwaves. We had a thermal imaging system with macro and nanoscale resolution from Microsange. And finally, an end-of-life test system for radar sensors from D-Space. So we had a special guest join us today. Karim Oak is a product line director at Analog Devices, and he talked with me about the 5G millimeter wave market. Let's look at a clip from that now. So Analog Devices has products covering the whole radio signal chain, including FR1 and FR2 frequencies. And we've talked a little bit about the sub-6 gigahertz bands, but what are you seeing in the 5G market for millimeter wave applications?
It's been very welcome to see that the near-term use cases are becoming a lot more grounded. That's what I'll start with. There's less of the autonomous cars, remote surgery that eventually might be monetizable real applications for the operators and other entities to go after. But as in terms of immediate revenue sources, we just don't see them as realistic items to pursue in the next 2 or 3 years. So we've been very pleased to see that the use cases are focusing more on the fixed wireless access and industrial use cases, which have a more concrete line of sight to revenue right now, as well as an expansion in the next 2 to 5 years. Specifically, we're seeing that operators are a lot more focused on fixed wireless access, which we think will drive revenue streams in the next 2 to 3 years, in addition to their quote-unquote traditional business that they have. This will be followed by an expansion of the mobility use case with industry and private use cases to follow. Similar to some previous discussions we've had, there will be a fixed and nomadic application of millimeter wave 5G at first, which will then be followed by the mobile use cases more widely deployed. As we all know and have seen in the last couple of years, the penetration is in the early innings. So it's primarily limited to developed economies with the means to spend more on this higher frequency band version of the network. But we're also seeing it expand. And over time, as the costs come down, we see the uptake actually going up worldwide. We're seeing an expanded deployment of fixed wireless access using 5G in FR2, supplementing the continued mobile rollout. So there has been a clear communication actually from leading operators in the US that I'm sure you've also seen, where there's a focus in fixed wireless access, both for sub-6 gigahertz to start, and then over time migrating over to FR2 as an added network resource. This allows them to generate new revenue streams using existing airwaves that they've already paid for. And there's also a significant growth in the fixed wireless access forecasts in the US first and worldwide next, which we're also actually seeing in our revenue profile that we're shipping into the market. And this is consistently by whether you ask the OEMs, the analysts, or our customers, which are the operators.
So it was great to talk with Karim about the 5G millimeter wave applications. And turning to the news, Vicor had a grand opening about a new 90,000 square foot facility that they added on to their corporate headquarters in Andover, Massachusetts. I was able to attend that, and it was very interesting. They have the first converter housed in package, or chip for short, fabrication facility that was expanded their capacity 45%, and it will get them to $1 billion in revenue, which is more than double what they're doing now. And I took a tour on this grand opening and was very impressed because of the green technology that they're using there. They have zero wastewater discharge, so recycle all their liquids, and they recycle 60% of their solid waste. So very good accomplishments there on both production capacity and green facility implementation. So we've also been following the hypersonic market, and we'll cover this topic in our June supplement. In the news, the U.S. Air Force successfully launched a AGM-183A from a B-52, and that's called a Air-Launched Rapid Response Weapon, or ARRW for short. And they did this off the Southern California coast on May 14th. And following the separation from the aircraft, the ARRW booster ignited and burned to the expected duration, achieving hypersonic speeds of 5 times greater than the speed of sound.
Wow.
So Gary, what did you see in the news?
I have another aerospace and defense story. Of course, GaN is not really new news as far as being deployed on land and marine radar systems, but at least I haven't seen it publicly on fighter aircraft. And now we have. Raytheon's prototype APG-79 V4 fire control radar uses GaN in the TR modules, and a prototype was delivered last year to the Naval Air Weapons Station, and it recently made its maiden flight on an FA-18. Of course, GaN's power density will extend the range of the radar, but the challenge is the radar had to be designed to fit the power and the cooling capabilities of the aircraft in the existing radar. So they seem to have done that, and we can expect to see GaN flying on fighters very soon. And of course, that's about GaN on silicon carbide. And we haven't heard much about GaN on silicon after MACOM trumpeted it several years ago and then partnered with ST Microelectronics to bring it to market. Now the two companies have announced that ST has fabbed GaN on silicon wafers and devices that have performance and cost they feel competitive with LDMOS and GaN on silicon carbide. So ST is proceeding to qualify and release the process, which ST says will complete this year. So that's an interesting turn of events.
Yeah, it's been a while on that, so I'll believe it when I see it. So turning to events, IMS is coming up June 19th to the 24th in Denver. And last episode, I reviewed some of the new things that were going to happen at the event this year. So I wanted to take a look now at the exhibition floor and some of its activities. And looking at the floor plan, I kind of immediately noticed that the semiconductor and component companies have really expanded their presence this year. Analog Devices has the largest booth, and they're also a sponsor of the networking lounges. So you'll see a few lounges around the area that you can sit down and talk with people in, which is nice and convenient. And we also had Corvo and Macom taking major booths. Millimeter wave products, Aravant is in the front with a long booth. TI, Amplion, P-Semi, and Teledyne, just to name a few on the component and semiconductor side. I wanted to note that Amplitech increased their space a lot this year, and they're sponsoring the welcome reception. And Quantic has all their companies together, so they have 7 co-located companies in one area. And on the test and measurement side, we see that Mari and Rohde & Schwartz have some of the biggest booths there, and there's also major booths from Virginia Diodes, Form Factor, Keysight, and AR kind of in the front middle area there. On the distribution side, of course, RFMW and Richardson RFPD have major islands. And I'm sure I missed some, but I just kind of wanted to call out some of the trends that I saw. You always get kind of a picture of what's going on from the IMS floor plan, in my opinion. But there is going to be 450 exhibitors or so, and should be a good show this year.
Yeah, it's really encouraging to see that layout, particularly after sort of the sparse attendance in Atlanta last year. And then, of course, we didn't have a real event in 2020. It was all virtual. And the exhibition, I note, has some interesting twists this year. The green circles that you see on the plan are actually the holes of a 9-hole miniature golf course that's sponsored by XMA Corporation. And if you complete all 9 holes, you turn in your scorecard and you have a chance to win a prize. You'll see the MicroApps Theater located in the upper left area of the floor plan, and just to the right is the Systems Pavilion. And we also will have a professional photo booth so you can get a photo for your social media accounts. It will be open during lunch, Tuesday through Thursday, and is co-sponsored by Wolfspeed and ourselves, Microwave Journal. So we're really looking forward to IMS 2022 in Denver, which is just a month from now, June 19th through 24th, and we hope to see you there. And that's it for this episode. We want to thank our sponsors, Analog Devices and RFMW. Analog Devices offers a semiconductor and integrated module portfolio that extends from the antenna to bits, as they say, and supports the major RF microwave markets, including wireless infrastructure, defense, and satellite communications. And RFMW is one of the industry's leading distributors, focusing solely on RF, microwave, and millimeter wave products. RFMW represents the leading companies in the industry, whether semiconductors, passive components, interconnect, or test and measurement. So please consider visiting our sponsors, particularly if you're at IMS. Thanks for joining us today, and until next time.